Welcome back to the Explainer. So let's just jump right into an incredibly frustrating but honestly completely fascinating scenario. Picture this. You walk up to your state-of-the-art, high-tech Tesla Model 3. It is an absolute marvel of modern engineering. But there's a huge problem. The car is totally unresponsive. You can't open the doors, you can't access the screen, you are officially locked out of your own car. And the culprit? Well, it's actually not the massive high-voltage battery under the floor. No, it's the tiny, traditional 12-volt battery that powers the basic electronics. Today, we're walking through the exact procedure for a locked Tesla 12-volt battery replacement. We're going to treat this not just as a standard maintenance chore, but as a full-on tactical rescue mission to wake your car back up.
This brings us to a pretty massive catch-22, right? It perfectly illustrates the unique challenge of modern EVs. How exactly do you open a car that requires electrical power to unlock its electronic doors when the very battery providing that power is completely dead? You can't just pop the hood from the inside because you can't even get inside. It feels like an impossible puzzle. But as you'll see, the engineers actually planned for this exact lockout scenario.
Think about a traditional gas-powered car for a second. If your battery dies there, it's an inconvenience for sure. But you just slide a physical metal key into the door, you manually turn the latch, you pop the hood release lever in the footwell, and boom, you're ready to jumpstart it. Simple. But on a Tesla Model 3, the door handles are entirely electronic. The hood latch, or the frunk as they call it, is electronic. So when that 12-volt battery flatlines, those systems are totally dead. We have to bypass the normal entryway entirely.
So here is our mission briefing. We are looking at a clear 5-phase sequence: the breach, the awakening, prepping for battery surgery, the 12-volt battery swap, and finally reconnecting and powering up.
Starting right off with Phase 1, the breach, focusing on front bumper access. Since the doors are a total no-go, our primary objective is to gain access to the front trunk. But without that electronic release, how are we getting in? Well, the secret is actually hiding in plain sight, right on the front bumper. It's kind of amazing once you know it's there. Tesla engineers hid an emergency back door specifically for this exact situation.
Okay, so here's where the tactical part really begins. First, you're going to locate the small, round clip bracket on the front bumper. It's usually the tow eye cover. Carefully pry and pull that small clip out. Now, behind it, you aren't going to find some old-school mechanical release cable. Instead, you just take out a pair of wires. Grab an external portable battery charger, like a jump pack or even a 12-volt power supply, and connect it directly to those two wires. The absolute second you introduce 12 volts to those wires, pop, the front trunk opens up. The latch releases electronically. Once you're in, just carefully tuck those small jumper cables back into the bumper and close up the bracket. You have successfully breached the perimeter.
Which takes us right into Phase 2, the awakening.
All right, the frunk is open, and we are staring right at that dead 12-volt battery. But hold on, we can't just rip it out yet. Our goal right now is just to give the car enough temporary life to open the cabin doors. Here is the protocol. First, open the black bracket or trim piece underneath the bonnet so the 12-volt battery terminals are fully exposed. Next, grab that same external portable battery charger, but this time connect the power jumper directly to the dead 12-volt battery's terminals. By doing this, you're essentially bypassing the dead battery and feeding power straight into the car's main systems. Suddenly, you're going to hear clicks, the screens might flicker a bit, and the car wakes up. While that external charger is connected, you can open the doors and basically start the car's auxiliary systems. The lockout is officially defeated.
Now for Phase 3, prepping for battery surgery and securing the cabin.
Okay, we've made it inside the car, but we have to secure the environment first, kind of like prepping a patient for an operation. You absolutely must navigate to the main screen menus and manually put the car into power off or sleep mode. You're basically telling the computer systems to shut down gracefully. Once the car is fast asleep, you head back out to the frunk and disconnect the 12-volt battery's negative cable.
Actually, wait, before you completely cut that power, there is a very specific physical prep step you have to do. You must open the front driver door, open the rear passenger door, and roll down all the windows. Now, you might be wondering, why on earth do we need the windows down? Well, Teslas have these frameless windows that automatically roll down a tiny fraction of an inch to clear the trim whenever you open the doors. If you kill the power with the doors shut and the windows up, you literally won't be able to easily open the doors again without risking some serious damage to the glass or the trim. So, leaving them open secures your access.
Now for arguably the most critical safety step in this entire explainer, the safe disconnect. You see, the 12-volt battery is just one part of the equation. There's a massive high-voltage battery under the floor that is continually trying to charge the 12-volt system through a DC to DC converter. We have to stop that from happening. To do this, go to that open rear passenger door. Physically pull up and pull off the rear passenger seat cushion. It just pops right out. Underneath that seat, you'll locate the main battery connectors. Your target here is to pull out one specific black cable plug. This is the high-voltage disconnect loop. Pulling this completely isolates the high-voltage pack from the low-voltage system. Now the car is truly, completely dead and safe to work on.
Moving to phase 4, the actual 12-volt battery swap, the core operation.
The environment is perfectly prepped. The high voltage is disconnected, and the computer is asleep. This next step is straightforward, but discipline is absolutely key. First, unbolt the tie downs and physically lift the dead 12-volt battery right out of the frunk. Second, take your brand new replacement battery and drop it firmly into place. Now step 3 is where you need to pay very close attention. Connect the red cable, the positive cable, only. Do not touch the negative terminal yet. We are purposefully leaving that circuit open for now.
And that brings us to the final phase, reconnecting and powering up.
We're in the home stretch. The surgery is done, but waking the patient back up requires a very strict sequence timeline. It's essentially a 1-2-3 sequence. Minute 1 was connecting that 12-volt red cable, which we literally just did. Minute 2 requires us to move back inside the cabin to reconnect the main high-voltage battery under the seat. And finally, minute 3 is going back to the frunk to connect the 12-volt negative terminal to complete the circuit. Reversing this order is a bad idea. It can cause arc flashes or throw a bunch of messy error codes onto the car's computer.
Let's just break down those final physical steps real quick. Head back to the rear passenger seat, grab that black high-voltage disconnect cable you pulled off earlier, and plug it firmly back in. You'll usually hear a really solid clunk from the high-voltage contactors when you do this. Then, pop the seat cushion back down and close it up, making sure it clips into place securely. Finally, walk back around to the front of the car and connect that negative terminal to the new 12-volt battery.
And at this exact moment, the main computer is going to boot up. The screens inside come alive, the interior lights turn on, the whole system resets. You can safely close up the black trim panels in the front, firmly close the bonnet, and you are good to go. The car is fully operational, running perfectly on its brand new 12-volt battery, and most importantly, it's no longer a 4,000-pound paperweight sitting in your driveway. Mission accomplished.
So we've walked through the breach, the awakening, the critical prep, the swap, and the precise reboot sequence. It completely transforms what looks like an impossible lockout into a very logical step-by-step rescue operation. So my question to you is, isn't it wild that rescuing one of the most advanced computer-driven vehicles on the road literally comes down to popping a plastic clip and crossing 2 tiny hidden wires? Knowledge really is power, especially when you're dealing with the power systems of your own vehicle. Thanks so much for joining me on this explainer, and I hope it gives you a totally new perspective on how your EV actually operates under the hood. See you next time.